We've talked about annuities, and we've talked about present value calculations, and we've been pretty thorough with all of those. We didn't spend quite as much time on net present value calculations, which are typified by numbers that don't come in nice, tidy packets, like the same amount of money every month for 30 years. In other words, you've got differing amounts of money collected over time, over a finite period of time, and in essence you may have to spend some money on the front end in order to, in essence, make everything, come out the way it should. For instance, if you buy an old building, renovate it, and then begin collecting rents on it and finally sell it, you've got some negative numbers, you've got some positive numbers, you've got some rents, you've got a lump sum when you sell the building. It's not the same amount of money every period. It's differing amounts. Uneven cash flows are the most common form of cash flow, and so it makes sense to spend a little bit more time on that. I should by now have emailed to all of you 5 questions. You're not going to be graded on these. This is just to get you acclimated to doing net present value calculations. Let's go through these, and I'm going to liberally use the Excel spreadsheet to reinforce the keystrokes you need to make. Henry wants to buy a property in foreclosure and renovate it. He expects there to be 3 years of payments coming in, and then at the end of the 3rd year of payments, he also expects to sell it. So the first thing that you want to keep in mind is he's buying something on day 1. That's not part of the net present value initial calculation. That's subtracted from the net present value after you've computed things. So you're going to compute what happens after year 1, year 2, year 3. When you get an answer for what the net present value is, then you subtract the amount of money that Henry spent on day 1. So the day 1 expenditure gets subtracted from your net present value calculation. That's the first point you've got to keep in mind. The second one is you've got 2 negative numbers. A negative number on day 1, but also a negative number at the end of year 1 as he's renovating the building. So when you're doing your net present value calculation, the first number is going to be the year 1 number, and that's a negative number. Year 2 and year 3 are going to be the annual rents that come in, and then year 4, you're going to combine 2 numbers, the annual rent and the amount of money he collects for the sale of the house. So you actually have 4 years of calculations, and after you've computed the net present value, then you're going to subtract the day 1 expenditure to buy the building. Let's look at this as we look at the Excel spreadsheet. I've got my walking mic on so that at least you can hear what I'm saying. Okay, here's what's happening. We have got a net present value calculation. So we go to the FX tab up here on Excel, and we know it's going to be NPV because that's short for net present value, so we'll double click that. The rate on question number 1 is 5%. It's spelled out in the problem. The first value is the year 1 cash flow, which is actually a negative number, negative $125,000. The second year is going to be the first rent, and that's $50,000. The next year is once again going to be rents, and that's $50,000. The last year, he's going to make $50,000 of rents, and he's going to sell the house at the end of the year for $450,000. You add the 2 together, that's $500,000. That's all that you have to put in. You hit OK, and the net present value is $380,000. But that's if he got the house for free. He didn't get it for free. On day one, he had to pay $250,000 for that house. So we'll put in $250,000 and we'll subtract that. So it's going to equal the $380,000 minus the $250,000. The net present value is $130,846. So in essence, at a 5% discount rate, he made $130,000 by getting into that 4-year investment. Good return. Now, question number 2. If I were to invest in a $1,000 bond that pays 4% per year, but which has semi-annual payments, what would the bond cost me if the market rate of interest were 6%? Okay, remember, it's a semi-annual bond. The annual interest rate is 4%. What would the semi-annual interest rate be? Well, 4% divided by 2, 2%. So, it's going to be semi-annual payments over the course of 2 years. Remember, there are 4 6-month payments left. So 2% of 1,000 is $20. So we go to the FX key, we go to net present value. The rate is not going to be 4%, the rate's going to be 2%. So 2% is the rate. 2% of $1,000, the first semi-annual period is $20. The next semi-annual period, $20. The third semi-annual period, $20. And the fourth semi-annual period, $1,020. I made a mistake, didn't I? Those of you that are paying attention see that I put in 2% as the rate. That is incorrect. The market rate of interest today on an annual basis is what? 6%. It says so on the second line. So, if we're getting semi-annual payments, that means we divide it by 2. The semi-annual payment is going to be 6% divided by 2. It's 3%. So our rate of interest is 3%, but then we had to compute 1/2 of 4% or 2% for each of the semi-annual, coupons that came in. So that's where the 2% came in. $20, $20, $20, and then $1,020 when you actually have the bond mature. We've got all the information that's in the problem. We're ready to calculate. It's a discount bond. It's $962. But we shouldn't be surprised by that. The $962 is less than $1,000, which means it's a discount bond. The bond was priced at 4%. The market rate of interest, or the yield to maturity, is now 6%. Market rates have gone up. When market rates go up, there's an inverse relationship. The price of the bond goes down. So we knew already that this was going to be less than $1,000 because we knew this would be a discount bond. Answer, $962.83. Okay, the next one is simply going to be a straightforward calculation. We will delete this. We are going to do a net present value calculation yet again. Our market rate of interest is going to be 3.5%. We are going to have 3 values. First we collect 4632. Then we're going to be collecting 5690. And finally, we're going to be collecting 6921. We will add all of those together. We get 16,029. That, of course, is assuming that the cash flows were all given to us for free. But they weren't. We paid $12,000 for it. So we put in $12,000. We take the first number and we subtract the second number. And our net present value after subtracting out the $12,000 cost of those cash flows is $4,029.38. Keep in mind, if it's a positive net present value, then it was worth investing in. This has a positive net present value, therefore it was a good investment for our company. Remember I mentioned if you changed one variable, it became a sensitivity analysis? We're going to make this a sensitivity analysis. We're going to go back to the 16,029 that we computed, and we're going to go to the FX button, and that brings up all the boxes we used for the formula. Instead of 3.5%, now we're going to use 8%. Everything else stays the same. We hit OK. The cash flows now are worth $14,661. When you subtract $12,000, the net value now becomes $2,661. So the value has gone down, but the net present value is still positive. Therefore, yes, it's a good investment. Even at 8%, that was worth $12,000 on the front end. So it's a good investment for both 3 and for 4. It's simply that the value has decreased at 8%. So the net present value is less in question number 4. The last one is a house question. And this one we've had some practice with already. It's going to be a present value question as opposed to a net present value question. And what are we solving for here? We're trying to figure out how much house we can afford. So, we'll go to the FX button. We'll try present value this time instead of net present value. We know what our rate of interest is. It's 4% on the house. The trouble is, it's monthly payments, not annual payments. So let's divide 4% by 12. Make it monthly. The number of periods is going to be 30 years, but guess what? We want months. So once again, we put in 30 years, but we multiply it by 12. So the interest rate got divided by 12. The number of periods got multiplied by 12. And all of a sudden, I think to myself, okay, we've been solving for payments for most of these problems, but this time we're not solving for payments because we know how much we can afford. We can afford to put in $2,600. Because I'm spending $2,600, I'll make that a negative number. I can afford to spend $2,600 a month. Future value is going to ultimately be 0 because the mortgage will be paid off. The payments are made basically at the end of each period, so I'm leaving this blank as well. I only have to fill in these 3 boxes. Everything else stays the same. Let me look at this one last time. 4%, 30 years, $2,600. It all looks good. I'm solving for the present value. I hit OK, and it says the present value is $544,000. I can afford a $544,000 mortgage for my house. If I have a down payment, if I've got cash available for a down payment, obviously that would increase the value of the house even more. One caveat, this has computed the mortgage, the debt service that you can pay each month is $2,600. It's saying that you can afford a $544,000 house based on those debt service payments. The only problem is, in real life, we would have taxes to be paid each month, and we would have some type of insurance to be paid each month. That is going to whittle away the $2,600 payment, or conversely, it would add on to the $2,600. So we either buy less house to account for the mortgage payments and the insurance payments, or we have to make a bigger payment each month than $2,600 because we have to put in the insurance and the ancillary costs associated with it. So one way or the other, you want to make sure that you always incorporate all of the costs in these problems. And if you can afford only $2,600, you better net out the other costs and then reduce the payment that you're able to make. So in real life, just keep little tidbits of information like that in mind. You'll get a much more accurate answer if you consider all the variables. Again, that's all that I've got on this calculation quiz, but I wanted to walk through this with you just to make sure you are clear on it. If questions arise and things are not clear, feel free to email me. Let me know what your questions are. Good luck with everything that you're doing.